All right, so we are picking up with 2E. I've already heard from a fair number of you that you're confused about 2D, which I am going to stay after class and work with people who have questions on 2D. So if that applies to you and you're able to stay, please do so that we can go over those questions. Tomorrow, I'm going to go over your Earth area project in class. And then finish up any of 2F that I don't finish today, which is probably going to be part of it because we've got a couple of pages of 2E left, and then we have 2F just because we got behind last week. So with the fact that we're finishing up chapter 2, that means next week you do have a test due. Test 2 is due on Wednesday. This week we have a quiz due on Wednesday, which is, tomorrow. So before I get started, any questions about kind of what we've got going on and all of that? All right, let me share my screen and we will get to it. So remember in 2E, we were talking about percent changes. And so now we're looking at percent increase and percent decrease. And so when we look at percent increase and percent decrease, I want you to see that we've got the new amount on the left-hand side, the original amount times 1 plus, and I have X percent, but this is just your percent amount. And it's not necessarily mean that the percent amount is what is going to be the variable every time. Sometimes we'll be given the percent and we'll be solving for a different amount. The reason why we write it over 100 is that this is converting the percent to a decimal. And then percent decrease is the exact same formula, except for instead of addition, we have subtraction. So if we look at number 1, it says the TV is marked at $447. The store is having a 25% off sale. What will be the new price of the TV after the discount? So we're doing a percent off sale. So this tells us we're going to be dealing with a percent decrease. And it says, what will the new price be after the TV discount? So we don't know the new price. Meaning instead of new amount, we're going to have X. We don't know what it is. Our original amount is $447. So plugging in what we don't know what it is after the discount, but we do know that that's equal to 447 times 1 minus 25 over 100. So in order to simplify this, we need to first convert the fraction of 25 over 100 to a decimal. That gives us X equals 447 times 1 minus 0.25. And why I wrote 27, I don't know. And continuing to simplify, we've got 447 times 0.75. And again, how did I get the 0.75? I subtracted 0.25 from 1. And therefore, our final answer is going to be $335.25. And that is the price after the discount. So that's what the sale price is. Okay, so number 2 says, due to a logging mill closure, Milltown's population decreased from 12,113 to 10,833 in 1 year. What is the percent decrease? So when we think about this, we went down, which means the 12,113 is our starting amount or original amount. And the 10,833 is the new amount. So if we plug those values in, we're going to have 10,833 equals 12,113 times 1 minus, and we don't know the percent change. So that's where our variable is going. Now we have 2 choices here on how to solve this. I could divide both sides by 12,113. If I do that though, I am going to get a non-repeating or a non-terminating decimal, which is going to make our work really hard in terms of trying to subtract and all of that. So the easier way to deal with this is to distribute this 12,113 to both terms here. So 12,113 times 1 is just 12,113. We bring that subtraction sign down. 12,113 times x is 12,113 x. So from here, we're just going to solve for x. So that means subtracting 12,113 from both sides. Rewriting, we're going to have 10,833 minus 12,113 gives us negative 1,280 equals negative 12,113x. So what that tells us is that the population decreased by 1,280 people. Our last step is going to be to divide by negative 12,113. And we get 0.10567, and it just keeps going on, right? It's a big long decimal, which is why I didn't divide by the 12,113 from the very beginning. So with these, when you're solving for the percent, you still have to multiply by 100 to convert that decimal number to a percentage. And so multiplying this gives us 10.567%. And it'll, in your homework, it'll tell you how many decimal places to round to, right? So we're going to round to 2 decimal places, giving us 10.57%. Is what the population decreased by. Okay. Thinking about what we did in number 2, I want you to try number 3. It says Don's salary increased from 4,200 per month to 4,300 per month. What was his percent increase in salary? So because we're dealing with a percent increase, I want you to use new equals old times 1 plus x. And you're solving for that percent. So it's up to you to decide what new and old mean. And send me your answer to 2 decimal places, please. So again, send me your answer accurate to 2 decimal places, please. Or I should say rounded to 2 decimal places. And again, when I mean 2 decimal places, that's after you convert it to a percent. So, because we're looking at a percent increase, the old salary for him is 4,200, and then the new salary is 4,300. So again, we don't want to divide, because if I take 4,300 and I divide it by 4,200, I get a long terminating decimal, okay? So instead, I'm going to distribute. So I get 4,300 equals 4,200 plus 4,200x. Subtracting 4,200 from both sides gives me 100 equals 4,200x. Divide both sides by 4,200. And I get x equals 0.023809, blah, blah, blah. Multiplying by 100 to move our decimal place 2 places gives us 2.38095%. And since I said 2 decimal places, we're doing 2.38% as our answer. Okay, so the next 2 problems that we're going to do, 4 and 5, I want you to star these because you have very similar homework questions to these. And so you're going to want to make sure that you have these examples at the ready. So number 4 says Alex's monthly take-home pay after taxes is $2,400. If he pays 20% of his gross pay, and all that gross pay means is what the pay is before taxes is taken out. If he pays 20% of his gross pay in tax, what is his gross pay? Now, first of all, do not take 20% of $2,400 and just add it on and say that's the answer. Because that 20% is of a different number, not of $2,400. So when he's paying taxes, his amount is going down. So taxes is a percent decrease because we are losing money, right? You pay it to the state, you pay it to the federal government, it goes away. So because we're dealing with a percent decrease, we've got the new equals the old times 1 minus x. So after taxes, this is his new amount. We don't know the before tax amount, but we do know the percentage. So if we plug our values in, we're going to have 2,400 equals the old amount we don't know times 1 minus 0.2. And again, where did the 0.2 come from? Well, 20% is equal to 0.2 as a decimal. So now we're going to subtract 1 minus 0.2 is going to be 0.8. And then we will divide both sides by 0.8. And we get 3,000. So I can't tell you the number of times I have students say, okay, this is a big no. This is why this doesn't work. If I take 2,400 and I multiply it by 0.2, I get $480, and 2,400 plus $480 is 2,880. Not what we want, right? So that is considered a 20% increase on the 2,400, but what we're trying to find is a 20% decrease on some unknown number. So that is why we cannot solve it this way. Don't do that. Do it this way. Okay. So number 5, again, kind of that idea of finding a percent of an original amount. A tax exempt school group received a bill of $164.78 for educational software. The bill incorrectly included a sales tax of 7%. So while in Montana, there is not sales tax, there are towns that have sales tax, right? Like Whitefish has the tourist tax, Big Sky has tourist tax. So we still experience sales tax in Montana. Rude awakening when I moved to Tennessee, we have like a 9% sales tax here, but we don't have income tax. And I can't tell you the number of times I'm like, oh, this is great. I know exactly what my bill is going to be when I go to the grocery store. And I still forget even after living here for 6 months. And I'm like, oh God, where did that huge amount come from? And I was not expecting it to be that high. But like I said, we don't have income tax. So I guess it levels out. I'd rather it wasn't 9% though, I'll tell you that much. Anyways, back to the example. Sales tax is considered a percent increase. So we're dealing with a new equals an old amount times 1 plus our percentage. So the bill was $164.78. So that bill included the sales tax. Therefore, the $164.78 is our new amount. We don't know what the original amount was, but we do know that they were charged 7% sales tax when they were not supposed to be. So again, 7% is 0.07 as a decimal. So in these formulas, you're always going to be putting your percentage number in as a decimal number. So we will combine like terms. And divide. And we end up with, they should have been charged $154. Again, if I were to take 7% of that 164.78 and subtract that off, we would not get the same answer. That's why you need to be finding that percentage of an original amount, which is why we need to set up and solve it the way that I've shown you. Okay, so I'm going to do one of these percent comparison problems and then one of the percentage problems that we have on our page. You don't have a lot of homework problems associated with those because then I want us to get into 2F, okay? So number 1 says the gestation period of humans is approximately 266 days and is blank percent longer than the gestation period of pigs, which is 115 days. So because the gestation period of humans is longer than the gestation period of pigs, we are dealing with a percent increase. And because we are comparing humans to pigs, pigs is our original amount, and humans is our new amount. So because we have percent increase, we're going to have new equals old or original times 1 plus X. So I want you to go ahead and send me your answer as a percent rounded to 1 decimal place. Okay, so if we, because again, pigs is the original amount, which would be our old, based upon the way I wrote it. Humans is the new amount, so we're gonna have human 266 equals pig 115 times 1 plus x. Again, we don't want to just divide both sides by 115, we want to distribute. So distributing 115 and through, we're gonna have 266 equals 115 plus 115 x. Subtracting 115 from both sides gives us 151 equals 115 x, which that shows you that human gestation is 151 days more than pig gestation, right? So we're saying what percentage of that original amount is that? Well, if we divide both sides by 115, we get x equals 1.3131. Does it keep going? 151. Let's see, 1.313043478. And moving this 2 decimal places, we get 131.3%. Right. So like I said, you don't have a lot of these, so I just wanted to do one of them. If you want to see more of these examples, you can look at the video in Eagle Online. I'm going to go to the next page and look at one of the ones of percentages of percentages. It's a crazy concept. So
I just have one quick question before we jump to that. How do we know which is old and which is new?
So when you're looking at, so when it says the gestation period of humans is blank percent longer than the gestation period of pigs, that's telling us that we're comparing humans to pigs and saying that it's greater. So that gives us the indication that pigs is our starting amount.
Oh, okay.
Yeah.
So whatever you're comparing to.
Right. So like in number 2, our life expectancy in Japan is blank percent greater than the average world life expectancy. That means we are having the average world be our starting amount and Japan being our ending amount.
Okay.
And then like for number 3, looking at median age of women, the median age at first marriage
And
of US women is percent less than men. So men will be our starting amount and women would be our ending amount.
yeah. Okay, so then this one's
So percentages of percentages. So we're going to describe each change in 2 ways. We've got the absolute change. And then we've got in terms of percentage points, and then the relative change in terms of percentage. And to give us more space, I'm just going to go down to number 3. The process works the same for all of these. So it says the percentage of Americans accessing the internet increased from 67% in 2000 to 83% in 2012. So if we're looking at the absolute change, we're just subtracting these. And what that looks like is we are going to do 83% minus 67%, which gives us a change of 16 percentage points, which honestly means nothing because we have to give this something that we're comparing it to give it magnitude. So that's why we look at what the relative change is. So for the relative change, remember we've got our new minus our old, that's compared to the old times 100. And you might, instead of old, what we have on, we've also got in our notes, new value minus reference value. Or you can also have new minus original over original times 100. Those are all ways that we would calculate the relative change. And again, this is coming from the notes on the first page of 2E, that box at the bottom where it says relative change. So again, coming up with the absolute change, just looking in terms of percentage points does not help us. But if we look at the relative change, our new amount was 83%. Our original amount was 67%. And we're comparing that to that original amount of 67%. So subtracting these, we get 16 over 67 times 100. And again, where does that 16 come from? 83 minus 67 is 16. So 16 divided by 67 is going to be 0.2388059. And it just keeps going, but we're going to say times 100. Which gives us approximately 23.88% increase. So if we think about that that's a quarter of the population got access to internet in 12 years, right? So it increased by a quarter. So we've got a quarter of that is increasing, which is a crazy amount when you think about the prevalence of the internet in 2000 to the 2012. And now even more, 10 years later, how much more it's increased. Okay. So we're going to look at 2F. And I want to preface this with 2F. When thinking about 2F, I want you to think about this in terms of currency exchanges, basically. So what we're going to talk about is, so I'm trying to find the notebook page to pull it up. We're going to talk about what we call the consumer price index, which has actually been in the news a lot with the insane inflation that we're dealing with. And the idea is that money in one period of time and money in a different period of time had a very different buying power. So what you're able to buy with $1 today versus what you were able to buy with $1 even a year ago, which is a little insane to think about, it's been that close, is different, right? And so in the economy, we treat those as different currencies, basically. So you have this idea of 2022 dollars and 2021 dollars even, or 2008 dollars, or so when we're dealing with CPI, we're dealing with the idea of currency conversion. We're converting prices from what the price was in, say, the year 2000 versus what the price would be now as adjusted for inflation. So CPI is how we measure inflation, and it's based upon a group of goods. So if we look at our box here, so we have an index number, which provides a simple way to compare measurements made at different times or in different places. The value at one particular time or place is chosen as the reference value, and the index number is calculated as follows. So you've got your index number is equal to your value over your reference value times 100. The CPI, or the Consumer Price Index, is based on an average of prices for a sample of more than 60,000 goods, services, and housing costs. So when we're thinking about those goods, that's like, what's the average price for a gallon of gas? What's the average price for a gallon of milk? A loaf of bread? Things that like everybody is using no matter what time that we're at in 1982 or 2022, right? Those are these goods and services that are going to be consistent. And same with housing costs. Again, what's the rent during that time versus what's the rent now? And so then we've got some other calculations for rate of inflation and then adjusting prices. So before we get into too many of these calculations, I want us to try number one on the next page. So we're using the table from 3.4. We'll go back to it, but it says, suppose the current price of gasoline is $3.50. Find the current price index using the 1980 price of $1.10 as the reference value. So we're going to find the price index. And so from the first page, we're finding the index number. So we're going to use the value over the reference value times 100. So to find your index number, we do the money now divided by the money in 1980 times 100. So plugging in, we're going to have $3.50 now over $1.10 in 1980 times 100. So 350 divided by 110 times 100 is 318. And our index numbers, we go to one decimal place. So it's going to be 318.2. So what does that mean? We're thinking about what does that mean? Well, if we considered 1980 to have an index of 100, which would be our base amount, that's indicating that prices are now 218% of what they were in 1980. That's how you would understand what that index means, okay? Which could be even worse been depending, or better, I don't know, it just depends on where they're measuring inflation right now. So number 2 says, what is the overall amount of inflation as a percentage from 1990 to 2000? So we go back to our table. How do we find our rate of inflation? So the relative change in CPI from one year to the next is found by CPI Y over CPI X over CPI X. What does that even mean? Well, the Y and the X have to do with the years, okay? So we are comparing 2000 to 1990. So what we're going to do is the CPI in the year 2000 minus the CPI in the year 1990 divided by the CPI in 1990 times 100. So this is still our relative change. If we remember relative change, it's the new amount minus the old amount as compared to the old amount, right? So where do we get our CPIs? Well, for this, we're going to get them from the table on the first page. So I need to look up the CPI in the year 2000, and we need to look up the CPI in 1990. So we've got this table here, and we're finding 1990, which has a CPI of 130.7, and we're finding the year 2000, which has a CPI of 172.2. So we're going to plug these values into our formula. Again, the CPI in 1990 is equal to 130.7, and the CPI in 2000 is equal to 172.2. So we're going to plug these into our formula. And let me know what you get. We will, let's see, go to 2 decimal places, please. Okay, so if we plug our values in the numerator, we're going to have 172.2 minus 130.7, which gives us 41.5 over 130.7. So we're going to take 41.5 and divide it by 130.7. And then multiply by 100, which gives us 31.75%. Okay, so really quick. Giving you the idea of what did inflation increase from 1990 to 2000, we have a 31.75% increase for inflation. Typical inflation, what the economists shoot for on average, or they hope for, which is so ridiculous to say out loud, but they hope for around 2% is about what the 1.5 to 2.5% is what they're looking at. I just Googled right now, from February of 2021 to February of 2022, we had a inflation of 7.9% in 1 year. And at this point, they're looking at, from March to March, it was actually 8.5%. So like our inflation right now, which is why everybody talks about it, is insane. So this is giving you an idea of like, where are they getting that number? How is that calculation happening? Okay. So number 3 says, if it costs $10 to fill a gas tank in 1980, what % of the same tank could you fill with $10 in 2000? So in order to do that, we need to pull the CPI numbers. So we're going to do CPI in 1980 and CPI in 2000. So again, we get those numbers from the table on the previous page. So if we go back that page, we're going to look at our table. CPI of 1980 was 82.4. CPI for 2000 was 172.2. So we're going to pull those over. So to figure out what percent, and I think on your homework, they maybe say what portion. I'm not sure how it's specifically worded, but so what we're going to do here is we're going to take our CPI in 1980 divided by our CPI in 2000, and then we're going to multiply it by 100. There's a problem on your homework that you're going to do this exact calculation, but they don't want you to multiply by 100. I don't know why. I'm just warning you so that when you get to it, they want it as a decimal number. Plugging our values in, we have 82.4 over 172.2. Which gives us, so 82.4 by 172.2, then times 100, we get 47.85%. And like I said, on your homework, let me see if I can tell you which homework problem that is specifically. It's number 3 on your homework. And it says, if it costs $3 to fill a tank of gas in 1960, how much of the same tank? So how much of the same tank? So it doesn't want the percent. So the homework says how much of the same tank. And that we would just do 0.4785 because they're just saying what portion of it. So they're saying you don't need to convert it to a percent. So this is number 3 on your homework, just so you know. So this drives home the idea of how our money changes value. So from 1980 to 2000, over in 20 years, you could only fill up half the tank with the same amount if we were looking at what it was worth. So number 4 says it costs $8 to fill a tank of gas in 1980. How much would it have cost to fill the same tank in 2010? So in order to solve for this, we're going to set up a proportion that says money in 2010 to money in 2000, or not 2000, 1980 equals the CPI in 2010 as compared to the CPI in 1980. So this formula is coming from the section on the previous page where it says adjusting prices for inflation. So I like this use of the two fractions because we've done these before, these proportions. We just cross multiply and divide. Our amounts in the bottom are considered our references. So that's what we're using as what we're comparing it to. So if we plug in what we know, the money in 1980 was $8. The money in 2010, we don't know. The CPI in 2010, we go to our thing, was 218.1. And the CPI in 1980, which we keep using, is 82.4. So I want you to cross multiply and divide and send me your answer in a direct message, please.
Okay, I think me and Brittany lost internet.
Yeah, you're back now.
Yeah, so I don't know where we lost off.
Okay, so you see number 4?
Yeah.
I'm just asking you to solve for X.
Oh, okay.
So if we cross multiply, we're going to take 82.4 and multiply it by X. And we're going to set that equal to 8 times 218.1. And 8 times 218.1 gives us 1,744.8. And dividing both sides by 82.4 gives us approximately $21.17. So I think this is the one that always like puts this all in perspective for me is number 5, because we talk about like, you know, needing a certain amount of money, and especially the idea of like why people have such a hard time buying homes now versus what they used to be able to, what you could maintain a life on. I don't know, I just find this subject really interesting, and obviously it's a very hot button issue because there's a lot of different opinions. But if somebody needed $20,000 to maintain a certain standard of living in 1976, how much would be needed to maintain the same standard of living in 2008? So this is, again, all we're doing is adjusting the price or adjusting the money for inflation. So we're going to do the money in 2008 as compared to the money in 1976, which is equal to the CPI in 2008 over the CPI in 1976. So I'm gonna let you do this one on your own. Send me your answer rounded to the nearest penny, please. So we plug in what we know. So the money in 1976 was 20,000. Which means we don't know how much money we need in 2008. But on the right-hand side, it says the CPI in 2008, which if we look at our table on the first page is 215.3. And then we want the CPI in 1976, which again, looking at our table is 56.9. So, what's these? No, no, maybe we will. I don't know. So cross multiplying, we've got 56.9x equals 20,000 times 215.3. So 20,000 times 215.3 gives us, what was that? 4,306,000, and that's equal to 56.9x. Dividing by 56.9, we end up with x equals 75,676.62566. Nearest penny is 2 decimal places. So x is approximately equal to 75,676.63, meaning 63 cents. So this is why we talk about the issue with prices increasing at a certain rate and wages not increasing at a certain rate, right? And so there's a big issue in our country that wages have not increased at the same rate as prices of goods and services, and therefore every year as things increase in price and our wages don't increase, we are literally earning less because we have less buying power, which is crazy. So cost of living increases should never be referred to as raises, because that's not what they are. It's just keeping your salary the same amount so that you can purchase the same Starbucks coffee every day or whatever you choose to spend your money on. I obviously buy a lot of Starbucks, but anyways, let's jump to number 8. So this is again an idea of showing how we can quantify as spending is changing due to inflation or not, or is it keeping pace with inflation or not? So number 8 says total spending on healthcare in the United States rose from 85 billion in 1776. Or excuse me, 1770. Oh my God, that would be crazy. 1976 to 2.7 trillion in 2011. Compare the relative change in healthcare spending to the overall rate of inflation as measured by the Consumer Price Index. So what we're doing, we want to find the relative change first. And remember, relative change is the new minus the old divided by the old times 100. So because we have talked about scientific notation and powers of 10, we know that 85 billion is 85 times 10 to the 9th. And we know 2.7 trillion is 2.7 times 10 to the 12th. When we're doing subtraction, though, we can't have them have different powers of 10. Okay, so in order for them to be equivalent so that we can subtract them, we are going to move these decimal places, meaning we're going to make 85 times 10 to the 9th become 0.85 times 10 to the 11th, and it's going to make 2.7 times 10 to the 12th, 27 times 10 to the 11th. And why is this helpful? Well, in order to be able to subtract them, they have to have the same power of 10. So plugging these in, we're going to have 27 times 10 to the 11th minus 0.85 times 10 to the 11th over the original amount, which is 0.85 times 10 to the 11th. We multiply it by 100 to make it 8%. So how does this help us? The 10s to the 11th, 10 to the 11th end up canceling out. What I'm saying is 27 minus 0.85 gives us 26.15 times 10 to the 11th. And we're dividing that by 0.85 times 10 to the 11th. Again, if I have 10 to the 11th in the numerator, 10 to the 11th in the denominator, because this is over multiplication, I can cancel those. And we're doing 26.15 divided by 0.85, which gives us 30.7647. And of course, that decimal keeps going, but we're going to truncate it times 100, which gives us a 3,076.5% increase in spending on healthcare. Crazy amount of money. So the question is, did that stay consistent with inflation? Well, to calculate inflation, we're going to do the CPI in 2011 minus the CPI in 1976 divided by the CPI in 1976. And I want you to see that this formula is just a relative change formula. We're taking the CPI in the new minus CPI the old divided by the CPI for the old, right? We're just using different values than those monetary values that we had. So inflation in, what do we want? Or CPI, excuse me, in 2011 is 224.9. CPI in 1976 is 56.9. So simplifying, we're going to have 168 in the numerator over 56.9, which reduces to 2.95, which when we multiply by 100 gives us 295.3. I guess they're going out two decimal places. 25%. So of course it didn't keep with inflation, right? We didn't see a 3,000% inflation increase. Well, we saw a 3,000% increase in spending. But not all of these are going to be situations where the prices changed greater than inflation. Sometimes we will have something that doesn't change, thankfully, as compared to inflation. So, I don't want to go through this last example in like the rushed 6 minutes we have left in class. I'm going to go over it tomorrow during the Wednesday session. So if you're not able to come to the session tomorrow, make sure you watch the video because I'm going to go over number 10, which has to do with how much computers have changed in price. And thankfully, relatively speaking, they've actually gotten cheaper than what they were when they first came out. Spoiler alert. So I know we did a lot today. So I want you to take some time, let your brain process it. If you need to step away from it, I completely understand. What we need to focus on for sure is the fact that we've got 2D due tonight. Tomorrow you've got quiz 3, which is over 2A through 2D. 2E is due tomorrow, and then 2F, the stuff we just did, isn't due until Thursday, okay? So tomorrow I'm going to go over the Earth Area project. As usual, there are already videos going over the project in Eagle Online, so if you can't make the session, I totally understand. But I would consider watching the recording that I'll end up posting, okay? So tomorrow I'm going over the project and I'll answer any homework questions. And then Thursday, we are going to get into unit 3A, which is going to feel like a completely different world. We're going to start talking about probability and something totally new. So if you hate this, wait a day, you'll get something new. Oh, all right, everyone. I hope that you have a great day. And I hope to see you tomorrow, but if not, I will see you on Thursday for sure. And if you want to stay and ask questions about homework, I am going to stay on. I'm just going to stop recording, okay?